Great. Thanks so much, Tim. Thank you, everybody, for joining us on our last webinar. This has been a very successful collaborative series with the DSpace and Fedora folks. Today's webinar is going to be about DSpace and Fedora, who are two of the largest open source platforms for managing and providing access to digital content with a combined global community of more than 700 instances, including national libraries, research projects, businesses, and universities. Joining us today is Michelle Kempton, Chief Business Officer, and Sandy Payette, Chief Executive Officer of DSpace, the newly formed nonprofit supporting both the DSpace and Fedora platforms. We're going to take a 60-minute look today at each of the repository platforms that highlight key features and selection criteria. I'm going to turn the call over now to Michelle Kempton.
I'd also like to add that we also have Brad McLean, who is Chief Technical Officer of the new DSpace organization, and he will be giving part of the presentation today as well.
Great, thanks.
So just briefly, for those of you that might not have heard, both the DSpace Foundation and Fedora Commons organization have joined together starting July 1st of this year, so a few weeks' time, to form the DSpace organization. So this will also be a nonprofit organization. So the two existing nonprofit organizations will go away, and the DSpace organization will take on supporting and enabling open technologies for our current and hopefully new communities. So under the DSpace umbrella will be the DSpace platform and the Fedora platform, as well as the Bulgara open source platform, and then we're looking at launching a new technology called DuraCloud. So today the three of us are here to talk to you about what are some of the key distinct features between the DSpace platform and the Fedora platform to open up what are the differentiators between these platforms and help you make the best choices for your organization. We also wanted to mention that both of these platforms are open source software repositories, so they really serve similar purposes to enable access, management, and preservation of digital content using these open technologies. Although the platforms are distinct in some of their key features for enabling this purpose, the overall mission of both these platforms is very similar. Together, they support, as Screen has mentioned, a community of over 700 organizations worldwide, and that is with a growth of over 200 in the last year. So not only is this a dynamic community, but it's also a very large community that the DSpace organization supports. And when you evaluate any open source product, you should really look at the communities behind them, because that is what drives the dynamic development and growth of the technology in the long run. It's not dependent on one single organization driving the product roadmap. Now I will talk about what are some of the key features and distinct features of the DSpace product offering. So first and foremost is DSpace is really a turnkey solution when compared to other open source platforms out there for management of digital content. It has many features which were designed for and used by libraries today, so it is library-centric in terms of the process and the workflows that are embedded within the solution. It is an application architecture, meaning that all of the pieces that you need to make the application work, be it the database, the web interface, the workflows, the data model, are all inclusive within that application. You don't need to build any extra components to get up and running using the DSpace platform. It is quite end-user feature-rich, which means that once you have a DSpace instance up and running, you can enable end users to search and browse the content within that repository. There's a built-in search engine, and also that content is exposed to the outside world via indexing search engines which pick up the content, such as Google, Yahoo, and the like. All of this makes it a very simple package to install and get up and running, but what is really unique about DSpace is that it is simple but yet sophisticated. It means that it has numerous features built into the application, which allows you to manage your content in distinct and complex ways that you wouldn't be able to do otherwise. So this is a visual overview of what the complete solution looks like. So you have somebody that produces the digital content, and we call that person the submitter. This could be a person of your faculty, it could be a student, it could be a researcher, and they use the web interface to basically deposit content in the form of an item, and that item is the raw content file itself, as well as any descriptive, structural, and administrative metadata which describe that content. That is all packaged up into an item. Items are related to what is called collections. So a collection is a set of related items. Collections join together to form communities. So you might think of a community as a department or a subject area within a given organization. Collections are topical areas within that department, and items are the very specific content objects that make up that collection. Once those items are submitted, the content then goes through a workflow process, which allows it to then be pushed into the repository or the archive, where it can be preserved through tools such as checksum checkers, and pushed into a number of storage management systems other than file systems. When you want to retrieve the content, the end user uses the web-based front end to search or browse what content's available in that repository, so then they can look at the content or potentially reuse the content for their own project. If you look at an overall scheme of the application architecture, you'll see three distinct layers that the application can be described. At the very bottom, you have the storage layer, where the raw bit files are stored either in a file system or a secondary storage management system, and you have a number of tools that do file checking, do file distribution, and produce audit trails around that content. You then have the database, which the default database is an SQL database, but you can also configure it with an Oracle database, which manages all the relationships of those items and stores the content that describes those items in your storage layer, in your file system. The next layer is the business logic layer. This is where all of the content management process happens. So here you have your search, which in the case of DSpace has the Lucene search engine bundled as a default. You have your browse tool. You have the handle server, which gives you a persistent identifier for the content which you have deposited in the archive, the workflow, and the authorization. On the top layer, you have basically what your front-end tools are that your end user is going to see for exposing that content. So you have your web interface, OAI, PMH protocol, different package ingesters and exporters, and statistics tools. So I guess what I can say which is distinct about DSpace is that you don't need to pull in any of these other components within the application. They all reside within the package. You do have the flexibility to change out some of the components, a few of them, but otherwise you can get up and running without finding a particular database, a search engine, or developing a web interface for the entire application to run. These are a few of the key library-centric features. There is a defined data model within the DSpace application. So, and I'll review quickly what that is, but it is a model that was based on how libraries tend to operate today in terms of their the content that they bring into the library and their curatorial process. Each item has a metadata schema associated with it, and you have the flexibility to use not only double and core, which is the default, but to use mods and metadata schema. There's a built-in submission and administrative workflow process, which again follows what a library might be practicing with other materials it's bringing into its central organization. You can define permissions around communities, collections, and even items in terms of who has the authority to accept or reject an item or change metadata around an item. And you can set up, there's an authorization stack that comes with the application, or you can also use LDAP or Shibboleth protocols to link to your own internal organization authorization tools. When we look at the data model, this is how it is organized. There are 6 streams, which is the raw data file itself. It has some administrative metadata associated with that 6 stream. 6 streams then roll up into bundles. Bundles have other objects and data associated with that item, such as a thumbnail, such as a text extraction for indexing. Those bundles then make up the complete item, and the item is a set of files which is described by metadata of a particular item. So let's say it is a journal article. You might have a PDF version, you might have a doc version, and you might have a image associated with it. So all of those together would make up an item. Items then roll up into collections, communities. So that is the data model. It is a hardwired data model into the system. So if it doesn't fit what your organization, the way that your organization operates, you don't have a lot of flexibility with this particular version of DSpace to change that. In the collection workflow, this would be the typical workflow process when someone has submitted an item into DSpace. There are 3 workflow steps, and in each of these steps, you can set up workflow pools and groups of people to administer a task at each of these steps. If you don't want to have any steps between submission and acceptance into the repository, you can bypass all the steps, and when somebody submits, it automatically goes into the repository. However, if you have a auditing or curatorial process, you can invoke these steps with groups and create work pools around each of these steps that the groups can pull from. In terms of end-use features, this is an example. You see University of Toronto of what their DSpace website looks like, and you can see by just looking at the front page, you have a search interface, you can feature different collections and authors, you can get an RSS feed that tells you what new items have been deposited in the collection. The website itself is OAI page compliant, so other organizations can harvest the metadata associated with the DSpace instance to put it into their own portal or what have you. The authors themselves can assign Creative Commons licenses to their works, so if they didn't want to assign a standard copyright to a particular item that they have created, they can use the Creative Commons license, which gives them a broader range of rights to assign to that particular item. And as mentioned, if the content is publicly available when it comes to the website, it will be indexed by Google and other search engines. And in particular, Google Scholar keeps an active list of DSpace instances and ensures those instances' public content is exposed through DSpace Scholar. So in terms of the ability to install and get up and running with DSpace, it is a very simple system. It runs on Linux, Windows, and a Mac, and with very little technical effort, you can get it up and running. It supports all the common file formats, such as doc files, PDF files, JPEGs, MPEGs. It supports multiple metadata schema. It comes with a suite of tools, such as batch ingest tools, batch export tools, batch import cross plugins that allow you to translate your data object into a DSpace object. You can set up administrative groups to perform certain tasks for managing collections and workflow. It comes with an authentication system. It's got built-in persistent identifiers using the handle system. It's got checksum checkers, a statistics package. So, in summary, a number of sophisticated tools, but yet in a very easy to install solution. DSpace has had its biggest success in managing the output of research staff and students and faculty within particularly the academic community. Roughly 80% of our current community is using it for this purpose. Here is a snapshot of some of what I call the traditional phases of DSpace. So if you just basically took the vanilla instance of DSpace and got up and running and imported your content, your web interface to your end user would look something like this. So here you see the MIT DSpace instance, which is one of the oldest running DSpace websites. On the top right is the newly launched Harvard DSpace instance that they're using to make all their scholarly output openly accessible. So again, you can see they look very similar, but one is a few months old and one is about seven years old. You see the American Museum of Natural History, which is not an academic institution, obviously, it's a cultural institution, but using it for a similar purpose in providing access to scientific publications. But then you're also starting to see the new phases of DSpace, and this is using a new UI component, which we call Mannequin, and this allows somebody that is running DSpace to really customize it to their look and feel and change the way that the items are displayed within the interface. And so here we have three great examples. The top right is the Afghanistan library, which is all the Afghanistan manuals, Afghanistan manuscripts from their archive that was digitized as a project at NYU. On the bottom left, you have Texas A&M. It's part of a federated repository network. This is a snapshot of what their part of that federated repository looks like. And on the bottom right, you have Policy Archive, which is a non-profit organization which is collecting all government policy into a central aggregated archive. Find out more about DSpace. I highly recommend you go to the DSpace org site. You'll see who's using DSpace, which has everybody that we've identified as a DSpace user, and a few extra links if you want to find out more information throughout our wiki website properties. Okay, so that's all I'm going to say about DSpace. Now I will pass it on to Sandy to talk about Fedora.
Hi, I'm Sandy Payat, and Chief Executive Officer of the new DSpace organization, the joined organization, and Executive Director of Fedora Commons, and we're in the transition phase, so that's dual identity. I hear there might be some static. If there is, please just note in the chat if that's still a problem. No, it's okay. All right. So what I'm going to do is try to focus on what the key features of Fedora are and why Fedora is distinct from DSpace. As Michelle said, both platforms have a similar purpose in terms of the mission that we have both at the organization and how these products have served libraries, scholars, cultural institutions in terms of managing their digital assets. I would say that DSpace was originally targeted at the institutional repository use case and was able to expand from there. Fedora was actually not targeted at any one particular use case, and that's why the name that's behind the word Fedora, the flexible, extensible digital object repository architecture, is kind of key. And so what I want to do is pull out a couple of key facets of what we might consider the Fedora brand, and the kind of the key things that you get with Fedora. And one is, of course, flexibility. Fedora is service-oriented, and that means that essentially Fedora is not a turnkey application, although we do have end-user tools for managing content in a Fedora repository. The essence of Fedora is that it's a service. The repository is a service. It's accessible to APIs and interfaces, and the companion services that go with Fedora can be thought of as a loosely coupled service-oriented architecture. So think of it as service-oriented. Another key feature of Fedora is integration with semantic technologies. We have a built-in triple store in Fedora. I'll talk more about that, but it really permits this notion of semantic linking in the repository and among the objects in the repository. Durability. Fedora was designed with the intent of the content living a long life, having a perpetual life that be desired, and so there are some what you might consider preservation sensibilities that are built right into the system. And scalability. Fedora was intended to be a highly scalable architecture, and we'll show you about some of our recent tests to prove that. So if we didn't have any one particular application or one particular use case in mind, Fedora has been generally driven by community needs and community use cases. So in the Fedora Commons organization, the predecessor along with DSpace to the current DSpace organization, we began some work with the communities to organize around some of the key problem areas that people are solving with Fedora. And I have before you here a slide that shows the current communities that we have formed around Fedora: preservation, archives, data curation, scholars repository, which takes a little bit to like a research platform perspective, the repository built in, and open access publication. So these are kind of the driving use cases, and what you see, applications and bundles of technologies are being developed with Fedora inside around these problem areas. So going back to the kind of key aspects of the brand, I'll just hit each one briefly. In terms of flexibility, flexibility is very much around the digital object model in Fedora, which is essentially a simple container model that lets you aggregate any type of content, any type of metadata. You can intermix local content, that's content actually stored in the repository, with external content, content you might refer to out on the web at large. And one of the key things in Fedora is this notion of relationships, being able to assert relationships among entities, in the Fedora digital objects, and we use RDS to permit that. Given that we have this generic model, we also introduced this notion of a content model, which is basically the ability to define and register particular patterns of these digital objects. For example, you might have a pattern for a particular type of object that is used to represent an image or a book or an article or a data set. And you permit the ability to articulate the rules of what needs to be on the object for it to fulfill the requirements of that pattern, to give the pattern an identifier and to actually register the pattern in the repository. From there, you can really develop your own data model at large in terms of all of the different types of objects that you might have in your repository, how they relate to each other, and how you can build workflows around them. So again, in terms of flexibility, with Fedora you get to develop your own data model or models, develop your own workflows. So again, very flexible. It does require some effort on the user's part to define those things. Briefly, the object model depicted here, this is the generic container model. I'll just note two of the key features. One is this package in the container that we call RELDEX, which is really a package of RDS in the object. Within that, you can have the ability to have assert properties about the object in a naturally extensible manner. There's no fixed schema, so whatever properties you may need to assert about an object, they can be put in there, and you can assert relationships from this object to other objects, any one object to any other object. And then you have the data streams, which are really the content streams, and they can be any type of media. Any number of things can be built into the object. Service-oriented, as pointed out earlier, Fedora is a service. It's not an end-user application. So that means that all of the functionality of Fedora is exposed through APIs. We expose those APIs both in a RESTful manner on the web and in a SOAP-based manner. This makes Fedora a really good choice if you are building a system where a repository is a component of that system. If you're building an enterprise system, if you're building a web-based system, so Fedora can fit into a broader system as one key component. And it fits quite easily and nicely because of this exposure of these well-defined APIs for managing and accessing content. Another key thing that we have here with Fedora is this notion of supporting multiple applications. So on the bottom, I have a diagram of four Fedora service. On the inside, it's very modular. The modules are configurable. They're replaceable. They basically support all the key things you need in a repository, everything from ingest to managing and accessing content to enforcing policies using the extensible access control markup language to storing the actual content and managing registries. But it's really at the top level where the APIs are, and that's where applications that you would develop would interface with Fedora. The core repository, again, has APIs for management and access of digital objects. The basic entity in Fedora is a digital object, as defined previously. There are APIs for searching the object registry, APIs for searching the RDS database, which is an index of all of the RDS that's in all of the objects. It's one big graph of all of the RDS across all objects in the database. Authentication is pluggable. The authorization is actually rather powerful and interesting. Again, we use the extensible access control markup language, which is an XML-based policy language. Policies can be defined for specific objects or classes of objects, the entire repository, and Fedora will automatically enforce them using the Sun StackMole engine. We have supporting services that sit alongside the repository, again, in this more listed coupled service approach. We have gsearch, which is a configurable search service backed by either Lucene, Solar, or Zebra, OAI PMH, and an ingest service. Ingesting is one of the most interesting features of Fedora. Using RDS, as I mentioned previously, you can say things essentially about these objects. You can insert descriptive properties. You can insert relationships from objects to other objects, outbound relationships from one object to another, and you can link to external entities. And again, all of this is indexed in the integrated semantic triple store. And there are two choices right now. There's Mulvera, which is a full featured semantic triple store with Sparkle query, that's the standard W3C query language, and then NCT store, which is a simpler triple store with a simpler query capability, but it's highly scalable. What's interesting about this is you can use the building blocks of Fedora, which are the digital objects, and this RDS relationship capability to do some very interesting things. A simple thing you can do is actually create collection member relationships. So you can actually create a digital object in Fedora that represents a collection, as in this case the Jeffersonian Architecture Collection. These are materials from the University of Virginia Library. And all of the children can actually have assertions in their RDS package about being members of that collection. And then all of this will be automatically indexed by Fedora. And at this point, you can query for members of collection. You can traverse these relationships. This is simple example, but it's a very common example in Fedora of using the RDS relationship. More interesting things you can do with the semantic linking, given that, let's take our previous example, you have this collection of these architectural images by Thomas Jefferson, you can then start to build an information network in the repository itself. Other objects can appear that originally were not conceived of in the context of this collection. For instance, letters by Thomas Jefferson from a different collection, possibly in a different unit in the institution. Those objects can be put in Fedora, and relationships can be asserted among those objects to things that were already there, such as this collection object. So, for instance, the letter by Thomas Jefferson provides context about this collection of architectural images. You can also point out of the world of the repository itself. So this collection object might have a reference, maybe for educational purposes, courseware purposes, to pointing to an external URL that's completely outside the context of the repository. Again, all this can be indexed, and all of this can be queried using Sparkle or SPL. Durability, another key feature of Fedora. The repository is built with this concept of durability of the digital objects in mind. The whole repository architecture is file-centric, meaning that every key characteristic of a digital object is in a file. There's an XML file for every Fedora container, and then all of the byte streams are also files. What's really cool about this is at the end of the day, if the entire Fedora system hits the dust, is destroyed in some way, as long as you have backup of all the files, you can completely recreate the entire repository environment, registries and all, including the triple store, just by crawling those files. And we have a rebuilding utility that does this for you. But this makes the system extremely durable, and we've tested this many times in production cases to prove the ability for this durability feature to recover the entire repository from sources. Other key features that are notable, automatic versioning and audit trailing, and replication of content. I'll note we do have a feature in Fedora called Fedora Journaling, where you can configure multiple following repositories, kind of a chain of Fedora replica repositories. But we're also now beginning our work with the Fedora Cloud project as a form of more advanced form of replication to the cloud. The scalability, this is always a big thing. Early on in the project, we had people saying we need this to scale to at least 10 million objects. And this is, 5, 6, 7 years ago. So we put it with that as a minimum scalability list. Fortunately, we have evidence now to how many millions of objects we can provide you data for right now. Our work with Carlsruhe and Sun Microsystems has given us the following statistics. Basically, we've been able to run a variety of tests on the repository of Carlsruhe under many different scenarios at the 14 million object level. The only reason apparently they stopped there is because we just ran out of disk space for the testing. But we have been able to prove that there is no linear growth in ingest or as the repository gets bigger. All of the numbers are flat and stable in terms of ingest. And we've been able to measure all other operations in the repository with excellent results. More recently with Sun Microsystems, this is very exciting. We're running tests right now, and we continue to ingest. We're up to 40 million objects, and we're seeing some excellent performance on the Fedora repository configured with Sun Open Storage, 40 to 75 ingests per second, and generally on all the other operations, we're seeing 5 times faster than any prior tests we've done. So we're getting some really good numbers on scalability with Fedora. Quick diagram of the Sun architecture for these tests. So in general, Fedora, again, is a very generic architecture and platform that can support many different types of applications. We, in the arts, humanities, and culture sector, have everything from public broadcasting with the WGBH's Open Vault, media archives, to some of our original Fedora projects, such as the Perseus Digital Library at Tufts and the Encyclopedia of Chicago, very media rich. We have some interesting applications cropping up in the area we call small archives, such as the Jewish Women's Archive. And in the sciences and just around scholarly communication and research in general, we've seen some very interesting systems emerge, very advanced research platforms such as the eSciDoc platform, again targeted at e-research. Public Library of Science has Fedora at its core for open access publishing, highly integrated with the semantic triple store Modera. We see Fedora for medical imaging type archives, as in the Sloan Kettering example, and many others. These are just a few highlights. And again, this is just noting the variety of application types and different institutions that highlight the heterogeneity of uses of Fedora. And here are a number of URLs to learn more. Of course, our website, which is we just released a new version of this website, our community examples and community forums, and our wiki. So now I'm actually going to pass to Brad, and he is going to answer some of the questions of how do you make sense of these two repository platforms, and why are they similar, and why are they different, how can they work together, and we'll give you a view of our future.
Okay, thanks, Sandy. I'm Brad McLean. I'm soon to be the Chief Technology Officer at DSpace. And as Sandy mentioned, we'll try to, if not answer questions, at least phrase, help to phrase the questions around the future of both DSpace and Fedora. So today, DSpace and Fedora are both two really strong, distinct communities. They have their own governance. And as you heard from both Michelle and Sandy, there are some really clear-cut distinctions between them. DSpace is very oriented towards being turnkey. Fedora much more on the flexible and modular orientation. And as you look down the list, you can make some fairly clear choices as to which platform makes the most sense for you based on the local resources that you have to put into customizing it. As DSpace is looking to both continue to support these two communities and then find opportunities between them, we're not going to be looking to rapidly drive right towards an immediate integration, but what we will do is try to support any efforts that move in that particular direction. So one of the things that we've said in the past is that in bringing DSpace and Fedora together, +1 equals 3, but actually the reality is probably a little bit more complex than that. Both DSpace and Fedora are today already collections of components. They both have some pluggable storage layer technology, so you can choose different ways to store things underneath them. In DSpace's case, we have multiple user interfaces. Fedora has user interfaces that have been contributed by the community. Both consist of tools for import and export and indexing. Both use third-party technologies to provide some of the additional capabilities we need for handling various formats and conversion and the things that go on around the edges of these systems. And so when we look at it, in truth, DSpace has a number of subcommunities. Fedora has a number of subcommunities. Those communities produce different components. And as we're looking forward, we expect that we will get to a place where we can start to utilize those components together as appropriate to solve real-world problems for each specific challenge or profile or solution bundle, as the case may be, that fits. Also, I think it's important to note that both DSpace and Fedora openly import and export their content in a number of formats. So, looking at what we have today, if you have a DSpace and a Fedora, or if you're trying to work between organizations that have them, we have capabilities already, just with what we have to federate repositories by moving, importing and exporting metadata using OAI TMH. You can move content around if you so choose, using METs and the storage protocols. And both systems are actually capable of using SRD at a storage layer, although you would not be able to commonly exchange the metadata back and forth if you were to do that today. So these are places where there's already existing technology. When we look out a little farther, we see that there's certainly the possibility of moving to using OAI-ORE for import and export between and among repositories. Fedora is already working towards a storage layer called Kubla, and there have been DSpace folks that have been involved in auditing and understanding that, and that is one of the technologies being considered around DSpace. And of course, the DSpace organization is working on developing a new product, which is the DuraCloud cloud storage system. And we expect that both the DSpace and Fedora code bases will have a migration path to allow them to use cloud storage via DuraCloud in the future. One of the ideas that comes up all the time is the question of whether or not you could take a DSpace and run it on Fedora, which commonly means that folks like the DSpace flow and user interface and data model and are interested in being able to express that over Fedora. And we do have some work that's already going on in that effort. There was a Google Summer of Code project last year that did a prototype. There's an additional one this year that's trying to move that closer to being an effective reality, and I think that we will be picking up with the community to see if there's interest in moving that forward into a production mode. Shifting to the communities, when we look at the two communities that are currently developing DSpace and Fedora, we notice that there are a whole bunch of common tools that we're using. We're already using the same source code systems and the same issue management systems, and we both use mailing lists and IRC chats, and we both have a large portion of our documentation out on wikis. And the DSpace Foundation will be merging some of those resources together, which is not to say that there's suddenly going to be DSpace and Fedora interspersed, but that the tools that we're using to support them will get closer together so that once you're a member of one community, you can potentially shift over to the other side and make contributions there as well. We think that these are efforts that are going to reduce the friction when folks want to do work that crosses between the two communities, and we're hoping that that'll act as an incubator for lots of interesting projects. As we look at what's going to go on with the communities in the future, we think that there will be common components. So DuraCloud is one of them. We think that our use of format migration tools and potentially our user interfaces will migrate in the direction of being common, simply because it doesn't make sense to have the two communities competing and overlapping around those pieces. We think both user groups have opportunities to learn from each other, which we've already seen happening at conferences, but we're hoping that we will find mechanisms to merge those together. And we note that at the end of the day, the majority of these systems are being used to export information out onto the web. And we think that there will emerge a set of techniques and technologies for grouping these systems together into larger systems using web integration. So in terms of progress, those common development tools I mentioned are already starting to merge. Source code repositories are going to be served out of the same system. At some point in the near future, we will start to use a common JIRA system, and we'll probably take a hard look at merging our wiki systems together. The coordinators for both the Fedora and DSpace projects are coordinating. We are talking to each other on a weekly basis and trying to get our plans in alignment. And as we work through the first few months of our new organization, we expect that we'll have aligned roadmaps to send out to the community. And we're also in the process of continuing the DuraCloud development and in working out how to integrate that with our existing systems. I mentioned the Google Summer of Code effort already. And so to sort of try to frame the question, one possible future looks sort of like this, which is DSpace is turnkey, but DSpace might be implemented to stay turnkey, because that's key to DSpace, but using Fedora underneath for its flexibility and modularity. The LibraryCentric profile that we use for DSpace may be a portion of a Fedora digital collection. We can, and on down the list, we can use the end-user orientation of DSpace to figure out how to package the semantic technologies you have in Fedora. But what I want to stress here is that this is part of the future. And so if today what you're trying to do is make a choice between DSpace and Fedora, then it's exactly these same characteristics that you can use to find the fit that's going to work out for your organization. If you're library-centric and turnkey and you're trying to do an institutional repository and you don't think that you're going to be changing your workflow, then it may make a lot of sense for you to look at the DSpace platform. If you have local resources that help you to integrate and develop, and you know that you've got heavy-duty customization and you expect that in the future you're going to be handling workflows and data types that are beyond what DSpace provides today, then the natural answer today is Fedora. And as we evolve this process, we think that when you look up 6 months or a year from now, there will be emerging obvious choices for how you use these two sets of technologies together, and that there will be successful migration paths from wherever your choice is today to those future platforms. So in closing, Michelle and Sandy and I would really like to thank all of you and thank Sun for what has been a remarkably successful series of webinars, and we're looking forward to your questions. And on that note, I will hand things back to Corinne.
Great. Thanks so much, Brad. And thank you, everybody, for participating in our webinar series that began back in February. We had some really great participants and great questions. And we look forward to having some more webinar series in the near future. So let's go ahead and, Tim, if we can open up the lines for Q&A. Really appreciate that.
Certainly. Again, if you would like to ask a question, please press *1. You will be prompted to record your name. Please state your name slowly and clearly. Once again, *1. One moment.
Any questions in the queue, Tim?
No, we have no questions in queue.
Okay, great. Well, let's address some of the questions that came in through the chat. So the first question comes from Lisa Wynn, and her question is, can display of a record be restricted to a select audience, for example, on-campus use only, on an individual item and or collection level?
So I don't know if it's a DSpace or a Fedora question, but why don't we both answer it in terms of the current platform. So if I understood this correctly, you were getting at the issue of fine-grained access control. And from the Fedora standpoint, using the StackMode policy language, you can ultimately restrict access to a user, a group, on a particular object or a particular object with certain features, with certain attributes. Ultimately, in Fedora, you could probably do just about anything as long as you could figure out how to write the policy for it. So that's the caveat, that the policy language is extraordinarily flexible, but it does involve having someone be a policy expert in terms of being able to author the appropriate policy in the repository.
So for DSpace, you can set authorizations at the item or collection level so that you can restrict access to a group and read-only or read and edit access depending on who that group is. What you can't do in DSpace today, and this is something on the roadmap for the next release, is you can't set an embargo period to say that this item is only restricted access
release.
Yeah, I should mention, using the EXACNA policy, you can do that kind of thing. You can set things to be restricted for certain periods of time, certain days of the week, all kinds of things. Again, you have to be able to manage the policies and write the policies appropriately. And that was Sandy speaking. I'm referring to Fedora. Yeah, that was regarding Fedora and the EXACNA policies in Fedora.
Okay, next question comes from Terry Barksdale. Is there a version for DSpace and Fedora to merge the functionality into one new product?
I guess I'll take that one. Is there a vision to merge it into a single new product? Probably not. There is a vision to find a rational profile for how would you use components of DSpace with components of Fedora. And likely the natural place to go with that involves using some of the UI components developed in DSpace with the underlying components of Fedora. However, we wouldn't see that as necessarily eliminating the DSpace product or merging them into one new product. We would see that as being one way to bundle the technologies together.
Okay, thanks. Next question comes from Vernon. Is the RESTful API now considered stable?
Okay, so I believe that Vernon is referring to the RESTful API for Fedora. Yes, it is stable, and with our latest release, the 3.2 release, it's more complete now. There were a few operations that hadn't been implemented in the RESTful API. Yes, is the answer. And in fact, our new administrative client, our web-based administrative client, which just came out in beta, the 3.2 is written using that API.
Okay, thank you. Next question comes from Walker Wheeler. How about migration plans and tabs from choosing either today?
Okay, so I'll take a crack at this one. So the question is migration tabs and plans from choosing either today. So I believe this, my interpretation of this is right now you're going to choose one or the other, although I will note that a number of institutions have already chosen both, and they run a DSpace on the front end for submission of content, and they run a Fedora on the back end as an archive for DSpace content and all other content. However, the point is migration tabs. There tend to be a number of techniques that people have already taken here that basically have to do with a dump and load strategy and some transformation of what's dumped, which is typically some output of XML and some files. We would like to have a kind of canonical example of that that we can provide to the community and support as part of the mission of the new organization. And so we're moving down that path.
Okay. Next question comes from, I had a little bit of a problem here on my chat window. Please bear with me. John Tilbury, you mentioned format migration tools. Do you have any timescales for this?
Let me see if I can tackle that. We don't have an explicit time scale for that today, except to acknowledge that this is a problem that is faced by anyone who has a repository with any content in it. And so today we have situations where people are addressing this issue in an ad hoc fashion because we don't have enough prior art on how to do it in a more organized and centralized fashion. And so we are noticing that that's a common concern across both of our existing communities, and that we think it's something that we need to embrace and find the correct framework for across those communities. As an aside, we've also highlighted it as one of the primary interesting concerns and use cases when you move out into a cloud storage environment where it would be cost ineffective to drag everything back somewhere in order to do a format migration and then stick it back out there. So we know that these are areas that we need to have solutions for.
Okay, great. Thank you. Next question comes from Chris Dietrich. I understand that Fedora is open source. Are there costs associated with using it for a repository solution?
You mean other than founding the DSpace Foundation?
So, this is a great thing of open source is free, but is it really free? It depends on which open source product you're talking about. Tony Staples of our organization says it's free in the sense that as a puppy is free. You have to put some effort into it. So more so with Fedora, less so with DSpace. There is some investment of resources in building the application over Fedora and doing some of the work around the data modeling. So you will have to invest some people resources. Otherwise, of course, the software is free.
Okay. Next question comes from Thorsten Lang. Are there more scalability numbers available? Is the shown ingestion rate independent from the total content? There's several questions here. Will it slow down while growing? Having hundreds of millions of objects in the archive with only a few per second being able to retrieve, won't it take ages if ever I need to migrate away? And which is better for this question? DSpace or Fedora?
All right. This is Sandy. I'll answer this. Currently, I would say that Fedora is better for this only because we've measured it and we, have at least some data on what you can expect. Performance, you have to qualify the answer based on what operations we're talking about. So we have given numbers for ingest, and that's, assuming some sort of an ingest job, just, either with parallel threads or single thread, calling the ingest operations on Fedora. Those numbers we have on the Sun system, we quoted between 40 and 75 per second. There are numerous ways that you can tune a system to improve that or to have multiple repositories running at the same time to improve that. There are also techniques for bulk ingest that we didn't talk about and that were not measured in those tests. In terms of retrieval, again, there are techniques if you're doing a massive dump and load that were not measured in the numbers that we cite, but at least you can know if you're going to write a job that's going to have to hit the APIs and pull something out, you can at least know what you're dealing with there. So I'm reading the rest of the question. Hundreds of millions of objects. So we have observed flat, if you look at the chart of ingest as the number of objects in the repository increase up to our 40 million tests, it's flat, meaning there's no kind of incremental growth or nonlinear growth. We've seen a reason that that shouldn't continue. Of course, there are natural limits to any system, so you could say, what's the maximum size of the registry table, which is a relational database, and that gets you into the question of what's the maximum size of, say, an Oracle table. We are subject to those limits as any system is, but right now we don't see any notable bottlenecks or notable growth, nonlinear growth rates on the performance.
Okay, great. Thanks, Cindy. Next question comes from Joe Fisher. Could you explain what restrictions the fixed data model in DSpace might impose compared to Fedora?
Okay, I'll take a stab at this one for DSpace. In terms of the fixed data model, there's a hierarchical structure, which is the communities, the collections, and the items. And if your content doesn't necessarily fit in that type of hierarchical structure, it is not impossible, but can be difficult to do a comprehensive workaround. So, in other words, to expose the item outside of that community and collection infrastructure can be challenging at times, although a little bit easier with the new Mannequin interface. It still can be challenging. The other thing is that it's difficult, although nothing is impossible, but difficult to express relationships between items, particularly if they are in different communities and collections. So you can have a number of bit streams in a given item, and those you can establish some relationships. But then if you want to establish relationships between items across collections and communities, that is very cumbersome and difficult to do.
Okay. Next question comes from Jerry. Any suggestions for a workflow that works with Fedora ingestion? Does Fedora support workflow?
Okay, so the question, workflow for Fedora. So there's not any, one generic workflow that we distribute with Fedora. So then you look to workflows that are built into applications, and that's similar to DSpace. So there is some aspect of a workflow built into Islandora. There's a workflow built into Muradora, which is another application on Fedora. But actually what we're seeing on the broader issue of workflow in Fedora is that despite our belief that we could put some generic workflow packages out there, the way people tend to use Fedora, they tend to have either a workflow engine already in place with a broader enterprise system, or they have, some sort of external orchestration engine that they're managing a workflow with, or they've built it into their very own application. So we don't have a generic answer, but we do have a community around this possibly forming to try to at least share the examples and possibly some of the components that people have used around workflows in Fedora. I'll mention the Hydra project as being an example of 3 institutions coming together with 3 different workflow solutions around Fedora. It's available on our website, and they're hoping to share their solutions.
Okay, great, thanks. Next question comes from Daryl Truman. Fedora slide has something about UPI Drupal. Can you expand on this?
Yeah, okay. And so the University of Prince Edward Island has built this Islandora system on top of Fedora, which is essentially, there's a module in there that integrates Drupal, the open source content management system on top of Fedora. And more interestingly, Sun Microsystems has also partnered now with UPI and Fedora to take this technology and also bundle it with Sun Open Storage and have an entire appliance that you can just drop in, and you can get the best of an open source content management system with an open source repository behind it with Sun Open Storage behind it. And so that's about what I can say right now on the Drupal Fedora front.
Okay. Next question comes from Lisa Gentle. Is there a tutorial on how to use DSpace as a front end and Fedora as a back end?
I'll answer. There is no tutorial because there is no implementation yet. We had a Google Summer of Code research project, which is looking at having DSpace in front end for the back end. But it is just a research project at this stage, and as we've all mentioned, as we move forward in our new organization, we'll look for integration points that can make those available to both communities as they become prevalent.
Great, thanks, Michelle. Okay, next question, and looks like our final question from Claude Vandenberg. Our content DM-based repository houses items that have restrictions on who can use them, faculty only, students, and faculty only, etc. If a student publishes a paper that includes such restricted materials, we do not have a way to control how it is accessed. How can DSpace and Fedora address this issue? Can either restrict the content within a submitted item or offer something equally helpful? We still want the student paper available to the public.
really restrict material at the item level. So you would have to put the other materials as a different item and change the authorization policy on that item. You can't change the policy per the bit stream level.
So in Fedora, you can write policies that can restrict in the manner you described at what we call the data stream level, which is one of the components in the Fedora object, or even around some of the attributes of either a data stream or the object. We have examples of these policies in the system documentation. If you go to the XACML policy, sample policies, you'll see examples of policies that do something quite similar to what you described.
Okay, I think this wraps the webinar for today. I don't see any other questions in the queue here. Again, I'd like to thank the DSpace and Fedora folks, Michelle, Sandy, and Brad, and also Carol and Morris for their participation in this webinar series. This webinar will be sent to all registrants of this webinar, and we will also have an archive available on our website. Right now, we're still in the midst of working on moving the archive up higher on the page. If you go to www.education-webevents.com, you can access the archive of all the webinars that we've had this year. Thank you, everybody, and we look forward to working with you all again soon.
Thank you. Thank you, everyone.